Integrated circuits have drastically changed the electronics industry and have become an integral part of our society.
Is it okay if I use your phone?
Okay. They are used in sophisticated electronics and computers, which are part of our everyday lives.
Hi, I'm not here now, but leave me a message and I'll get back in touch.
Hello, comma. My name is my name. I'm using head movements to move the mouse cursor around and speech to do all kinds of words and commands.
These computers are used extensively in research and development to improve the quality of our lives.
Voice console, wake up. Press button, period. Go to sleep.
The modern electronic era bloomed when thousands of transistors and other electrical components were integrated on a small slice of crystalline material. Today's chips contain millions of transistors and are the heart of the microelectronics, communications, and computer industries. Inside a computer, there are rows of these tiny devices, each one capable of storing information or executing hundreds of millions of operations a second. Integrated circuits have evolved from bulky vacuum tubes and transistors and are fabricated in technological centers like Silicon Valley. It all begins with the growth of pure silicon crystals. Silicon is the common element found in sand. It is 28% of the Earth's crust and second only to oxygen in abundance. The silicon from the sand is refined and purified as polysilicon chunks. The purified silicon is then heated to a molten state. A small solid piece of single crystal called a seed is gently lowered into a rotating vat of molten silicon. Using the cubic atomic structure of the seed as a pattern, a new crystal will form as the symmetrical extension of the original seed. The hot liquid silicon in contact with the seed begins to cool and solidify as it is gently pulled from the molten region. The cubic atomic structure of silicon consists of atoms with 4 electrons in their outermost shell. In a perfect crystal and at low temperatures, each silicon atom bonds with its 4 neighbors. There are no free electrons to conduct current. At room temperature, however, the silicon crystal has enough thermal energy to free a small number of electrons. These free electrons conduct current, as do the holes where the electrons have been. This conductivity can be increased by adding impurities called dopants. Dopants are elements which are similar to silicon in atomic structure. There are 2 types of dopants. N-type dopants, like arsenic or phosphorus, have 1 more valence electron than silicon. P-type dopants, like boron, have 1 less. When some silicon atoms are replaced by arsenic or phosphorus, the crystal is called N-type, due to the extra electrons or negatively charged free carriers. If boron is used, the missing electron behaves very much like a positive carrier. The crystal is called P-type. These free electrons and holes move through the crystal, conducting electrical current in response to applied electrical fields. After 48 hours of growth, a single crystal results from the liquid melt. The ability of silicon to be either a poor or a good conductor by fine control of dopant concentration makes silicon a member of a class of materials known as semiconductors. The shiny rippled surface of the crystal is ground to form smooth, uniform ingots. A curved diamond-edged blade saws the ingot into wafers that are as thin as possible without being too fragile and difficult to handle. The wafers are scrubbed and the edges are rounded off and beveled to reduce chipping. The wafers are then ground smooth on both sides to obtain a consistent flatness and thickness from wafer to wafer. They are rinsed and etched in chemicals to remove surface contamination. The final polish is done on only one side of the wafer. The characteristic mirror-like luster is free from scratches and contamination. The wafers are measured for resistivity, which is a function of dopant concentration. They are inspected, packaged, and sent to fabrication areas, where they will be made into integrated circuits. Meanwhile, teams of engineers work together to design circuits that will be fabricated on the wafer's surface. In this facility, over 100 specialists are often required to design the next generation of a microprocessor.
You can actually increase the number
The
of
organization of a design team corresponds to the organization of a completed chip.
Right now our iCache is like 32K.
So let's at least offer them an option which gives them the performance.
Computer architects working at the highest level of abstraction